Hello friends, here we have another project from 123 projects. This project is about providing protection against overloading and overheating to a distribution transformer. First of all, we will take a quick look of components. This project is made by 8051 processor. Chip number is 8089S502 from Atmel microcontroller. Here is a Darlington pair array IC which is ULN2803. Here these two are relays to switch on or off or disconnect transformers from the distribution line. These are connectors for physical connections. Here we have a power supply transformer which will give or provide a power supply AC 12 volt source, and this 12 volt AC will be fed to this bridge rectifier. Then the supply goes to filter capacitor and it will become a smooth DC. Then after, the 12 volt is available at pin number 1 and relay and buzzer supply pin, while this microcontroller, this ULN2803 logic supply, this clock generator and this ADC 0808 along with this LCD will get regulated Humphrey 5 volt supply from this 12 volt with help of this voltage regulator which is 7805, which is positive voltage regulator. Here is a CT which will measure a current flowing from distribution line. Here is a main transformer which is for 400 watt capacity, and another is a reserve transformer for low capacity. It is for 200 watt. Okay, both of these are unity transformer, that's why they are so big. Here is a buzzer for audible intimation. Another protection of the transformer is overheating. This CT will measure current flowing from the CT, which will acknowledge the microcontroller with the help of ADC, external ADC, analog to digital converter with 8 channel, that how much current is flowing from the CT. But there is another sensor called temperature sensor fabricated here, LM35, which will give information about temperature of connected transformer. This sensor can be attached here physically, so then they will measure a temperature of the body of this distribution transformer. We can attach it, but for demonstration purpose we can heat them with solder or a lighter or a candle light or something to demonstrate the overheating. For that purpose we have left it alone. Okay, here are capacitors for signal conditioning. Here is a signal conditioning circuit for CT. There are 1N4007 diodes in bridge format, 100 ohms resistors in parallel, so there is a 50 ohm resistor as a bleeder resistor across to output of CT. This red LED is for power indicator. These resistors are for current limiting resistors. They are from 1 kilo ohm, which comes from a microcontroller pin. Here is a crystal oscillator of 11.0592 MHz. This black and the blue are same. They are pull-up resistors. Here is a preset for reference voltage adjustment. Here are 3 LEDs. Red LED is for system shutdown. Yellow LED glow. It means that reserve transformer is activated and load is more than 400 watt. When the red LED is blink or on, it means the load is more than 600 watt and system is shut down. If this green LED is light up, it means load is less than 400 watt, so only the main transformer is active and reserve transformer is bypassed or switch off. This buzzer will sound when any error occurs or when the project restarts. Okay, we have given 230 volt supply from this black cable, AC code. Here is a load bank made by bulb holders and bulbs. This load bank will demonstrate town load of the town, electricity load of the town varies as per time. The peak hours loading is different and off peak hours loading are different. Here we have attached another bulb holder to demonstrate a normal quarters loading or something else. So there are two distribution lines, two sending lines from this transformer, and we have used two transformers. If the loading is less than 400 watt, it means if the loading is in capacity of one distribution transformer, only the one distribution transformer will give a supply to this demonstration holder and also for township. So the total load consumption of these two load banks is less than 400, so then this transformer will drive all the supply. If the loading goes more than 400, the second sending line, second distribution line loading will be transferred to the 200 watt transformer, and main distribution lines loading will be available at normal on 400 watt capacity. If total loading of this bulb holder, this distribution line and this distribution line, the system will detect that from the current and will shut down both the transformers and the supply will be stopped to the both distribution lines. It is for giving protection to distribution transformers. Let us see a demonstration of this project. And if the temperature goes over 70 degrees centigrade on one of this temperature sensor, it will shut down both the distribution transformer and system will be shut down automatically. It can run more faster, but for display purpose or a demonstration purpose, we have add 2 or 3 second delay between all the calculations. Let us see the demo. So now there is no loading. This load bank is off. This is also off. First we will attach 100 watt bulb in. Now we have attached a 100 watt bulb to this bulb holder. So the total consumption is 100 watt. I'm using it because you can see loading less than 400 watt, normal condition. Temperature transformer 1 temperature 34, transformer 2 temperature 34, normal condition less than 400 watt. What happens if we add more bulb to a distribution line? So now it is 200 watt plus 100 watt, it means 300 watt. So the loading is less than 400 and normal condition, and you can see the green light is on, which indicates that this is normal condition. What happen if we add one more 200 watt bulb to a township load bank? We'll measure now. Load is greater than 400 watt. Reserve transformer is activated. You can see the yellow LED is light up. So now power supply to this distribution line, the bulb holder, single bulb holder, which demonstrates a low side distribution line, is driven by this transformer, which is reserve transformer, and the more power, more consuming load bank or more consuming power grid is driven by this big transformer whose capacity is 400 watt. So now the total consumption is 200 plus 200 means 400 plus 100 means 500 watts. So it is greater than 400, but it is in the range of this both of this distribution transformer. Total capacity of this system. What happen if we add one more 200 watt bulb? It means it will become 700 watt. Then the system will shut down and you can hear the sound. The red light is on, buzzer is ringing. Load is greater than 600 watt, system off. It will not start automatically until we restart the system, because it is a problem of loading which cannot be rectified automatically. Let us take a second demonstration of temperature sensor. Now the temperature sensor demonstration. Now I am applying a solder which is preheated on transformer 1. You will see the temperature of transformer 2 in next scanning. 55. If the temperature goes over the range is 70 degrees centigrade, it will switch off the system. Now the bulb is on, but it will switch off the system. Buzzer is sounding. Temperature is 70 degrees, 78 degrees. It is more than 70, so the system is shut down. It will stay in this condition until we reset the system. We have to wait for the temperature sensor to become cool.